please welcome Grace. Grace is a Java champion and a developer advocate at IBM, working with OpenTelemetry, MicroProfile, and cloud technologies. She has been with IBM since graduating from Exeter University with a degree in biology. Grace enjoys bringing varied perspective to her projects and using her knowledge of biological systems to simplify complex software patterns and architectures. As a developer advocate, Grace builds POCs, demos, and sample applications and writes guides and tutorials. She's a regular presenter at international technology conferences and has authored a book on reactive systems. Grace also has a keen passion for encouraging more women into STEM and especially technology careers. So, hello,
Thank
Grace.
you so much for that introduction. Hi, how are you?
Amazing. Thank you very much. Good to have you on the conference. When I was reading through your biography, right, biology and then going to IT first, it seemed like not an obvious connection, but I remembered recently a friend of mine was saying that he has actually like reversed not the career, but he started with IT and then he found as a hobby, he started to read more about, I think, microbiology. And he said that there's really lots of connections between the models and the architecture, etc., and so on. So from your perspective, what are those connections that are like the most obvious ones that the human or nature biology and the IT systems that we're designing have in common?
I mean, a classic example is your AI models, especially when we start looking at things like there's been several models based off ant behavior and ant colonies, because nature is fantastic at being able, sort of machine learning, those kind of things. It's fantastic at being able to really make efficient systems that work with the minimum number of resources, but with the maximum output. And so, we've been taking more and more recently in recent developments and innovations, we've been taking that inspiration from nature and replicating it in these algorithms and sort of methodologies we use within software. It's just amazing to see this mix of the two subjects.
Definitely it is, and it's also pretty inspiring. So I am now actually very interested to read a little bit more about this aspect of things. I have read one paper where the efficient transport communication was designed using, I think, mold and putting like a little bits of sugar or something on the map and making mold just make the optimal routes in between. Yes, exactly. Yep. So those kind of models, they are, I mean, probably possible as well to model in artificial computer environment, but also amazing to see how the nature solves it without the computational capacity that we have. So,
it's amazing.
Thank you very much for joining. And now, without taking any more time from your presentation, the stage is all yours. So please share your presentation whenever you're ready.
Thank you so much. Perfect. It's there. Great. So all the tech seems to be working. And thank you guys for joining me. I can't believe Garrett was up that early, but respect to him. It was fantastic to see his presentation. And thank you guys for staying on for mine. So as has already been introduced, I'm a developer advocate at IBM. I did biology, came to tech, had a bit of a whirlwind journey, not necessarily your stereotypical route in. So if you guys have any questions on that or want to reach out to me on that subject, feel free. My Twitter handle is on the screen there at GraceJansen27. I will try and get around to questions at the end of this presentation. If there's anything I don't get around to or anything you fancy asking me later on, whether it's related to this subject or biology or whatever it might be, feel free to reach out on Twitter, or also my LinkedIn details will be at the end as well. So this presentation, I'm going to be focusing on sort of stepping through that looking glass, trying to achieve really effective observability for our cloud native applications. So how do we achieve this? Well, let's take a closer look. So what do I mean by through the looking glass? Well, if anyone's familiar with Lewis Carroll's Alice in Wonderland series of books, then there's a sequel to the original, which is Alice in Wonderland, which is essentially called Alice Through the Looking Glass. This was just sort of the next iteration upon the book, the next book in the series, and there's been a movie made about it. So you might have seen that recently. It's only a few years old, from Disney. And in this book, or in this film, Alice passes through a mirror over a fireplace and finds herself once more in an enchanted land, in Wonderland, essentially. And this sort of phrase that's been coined by Lewis Carroll has essentially been used for sort of a metaphor of any time the world suddenly appears unfamiliar almost as if things were turned upside down. So similar to looking out from inside the mirror to find a world both recognizable and yet completely upside down. It's kind of like a portal or a gateway this mirror is acting as to that magical world to allow us to see things that we wouldn't normally be able to see. Now, for anyone who's not necessarily a literacy nerd, you've probably come across this metaphor before in other mediums. So if anyone can think of an example where someone steps through a mirrored surface, finds themselves in a world that they wouldn't necessarily be able to see otherwise, and there's references even to Alice in Wonderland in it, like the White Rabbit. If you've not guessed it already, it's this film, The Matrix. So this is actually based upon that sort of theory of stepping through this portal, seeing things that we wouldn't necessarily be able to see. And actually in this film, if you think about it, going back right to the beginning, I'm just going to pause that GIF. Neo gets woken up in the beginning of this movie by a computer sending him a direct message instructing him to follow the white rabbit, the lady with the rabbit tattoo. Towards the middle and end of the film, it talks about you take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. You take the red pill and you stay in Wonderland, and I show you how deep the rabbit hole goes. So there's references throughout to this original metaphor used in Alice in Wonderland of being able to use this portal to see unexpected things. And that's essentially what we're trying to achieve when it comes to our distributed cloud native apps. We need to be able to fully understand how our apps are behaving in real time to be able to monitor them and ensure that we're providing a reliable and responsive service to our end users. But because our applications are now distributed, they might be in multiple different cloud environments, they're being deployed into this sort of very chaotic and sometimes confusing environment. It's important that we are able to utilize and build an effective portal to be able to actually achieve understanding that effective observability, to understand how our applications are behaving. So that's why I've used this metaphor of looking through the looking glass. How do we build that effective looking glass for our own applications? So in this presentation, I'm going to quickly go through sort of why we need observability. What do we mean by this term? Because it can be used in multiple different ways. It's quite a broad term. How can we do this within our own applications? And then going into specifically a couple of open source technologies that can enable us to do this, like OpenTelemetry and MicroProfile. I'll then show a brief demo and then have some resources at the end in case you want to have a look yourself and try it out for yourself. So the first step is sort of the why. Why do we need observability? Why am I even giving this presentation? Why are you guys here? Why do we care? So innovations within cloud infrastructure, really it's all about this sort of evolution that we've come across when it comes to our infrastructure and our application. So where we used to have for our infrastructure sort of a single core, now we're taking advantage of things like multi-threading, multiple cores, we've got virtualization, containerization. Essentially, we've gone into this more complex distributed environment that essentially brings with it advantages, but also brings with it its own problems in terms of being able to understand how our application's behaving, ensuring it's behaving in a way that we were expecting, and making sure that it's remaining responsive and sort of behaving the way we want it to. And at the same time as this evolution in our infrastructure, we've also had an evolution in our application architecture. We've gone from a more monolithic style to, again, more distributed sort of microservices it might be, but it might also be macro services or serverless. Again, more sort of distinct individual units that might be responsible for much more sort of restricted or smaller tasks. So we've, again, increased the complexity here when it comes to our applications. And so it's important for us to be able to have this observability. Now, with these evolutions, you might be asking sort of, why do we bother going to the cloud? We've introduced more complexity. We've introduced more sort of potential issues and problems. So why are we moving to the cloud? Why do we care about it? And I think really the answer is this. Hopefully you guys have seen Toy Story, so you'll get this one. If you've not, please go and watch Toy Story. There are some fantastic Disney movies I'm mentioning here, so take that away as homework. In Toy Story, we have these aliens and they get super excited. And that's how we feel when we talk about the cloud. It's this feeling of, ooh, the cloud. Because we get excited because the cloud offers a bunch of different innovations, technologies, capabilities, and benefits like increased resiliency, speed, robustness, being able to be highly responsive and resilient. So loads of these different speed, different characteristics are what gets us excited, because we can introduce those into our applications by using this style of application architecture and infrastructure. However, it doesn't always feel like this when it actually comes to developing for the cloud. Often it can feel a little bit more like this, because we are in a more complex world. There are things that are now a little bit harder when it comes to using this distributed environment, especially when it comes to understanding why our behavior or why our applications might not be behaving in a way that we expect them to. What is that? So how do we achieve that root cause analysis? Understanding how we can achieve incident resolution is a bit harder. We still have to answer these questions of sort of what's the overall health of my system? What is the root cause of errors and defects? What are performance bottlenecks? Where is my application being held up? Where is it not performing as it should be? And which of these problems could impact my user experience? And all of that becomes a lot harder within this environment. So it's important that we enable observability to try and tackle this. And this is reflected in sort of application methodologies for cloud native that have been sort of iterated upon and developed for more modern applications. One example of that is the 15-factor app methodology. This is essentially an extended version of the original 12-factor app methodology. And one of the newest, there's 3 additional factors in this from the original. They are API first, telemetry, and authentication and authorization. If you're interested in this application methodology, I've got a link at the bottom here where I've got an article that goes through it in a great deal in more detail that you can check out. But the one I wanted to focus on here is the fact that, it's really calling out to this fact that telemetry is now a really important, critical aspect for our cloud native applications. Being able to monitor our apps in real time, to be able to understand performance, health, and other key metrics in this complicated and highly distributed environment is really being called out in many methodologies as an important step for us to be able to ensure we're building effective cloud native apps. So that's kind of the why behind we're excited about the cloud. We want to utilize the cloud effectively. We want to build our applications to be cloud native. But in order to do so, and in order to be effective on the cloud, we do need that telemetry, that observability. What do we mean by this phrase, though? What is observability really referring to? So in general, I've got this sort of overview here of a generic description of what observability means. So observability is the extent to which you can understand the internal state or condition of a complex system based on its external outputs. So it's really aiming to provide sort of granular insights into the behavior of systems, along with hopefully rich context. However, when we start looking more specifically, because this is kind of very general, could be applied to most general systems. What about when I'm talking about IT and specifically cloud computing? So how does this term really impact us as cloud native developers? And really what I think it comes down to is observability is all about essentially aggregating, correlating, and analyzing a steady stream of performance data to be able to help us monitor, troubleshoot, and debug our application in the network. So essentially, this is the definition that we need to be focusing on when it comes to observability and whether we're enabling it effectively within our application. So we're going to take a look at how we can achieve this. How can we aggregate, correlate, and analyze performance data to be able to monitor, troubleshoot, and debug? And we're going to take a look at some open source for that as well. So the how. We've looked at the why, we've looked at the what, and now we're taking a look at the how. How can we achieve this within our own applications? And for this, I think there are 3 steps. Overall, implementing observability is conceptually a fairly simple concept. But to actually enable it in our projects, there are 3 steps that we need to make sure that we're doing. The first step is we have to actually instrument our systems and applications to be able to even collect any data at all. If we aren't instrumenting them, there's going to be no data to collect, no data to analyze, correlate, or store. So when we're instrumenting our systems, it's important that we're looking at a variety of different metrics, including things like traces and logs and generic metrics. And we'll get onto that a bit more in a minute. The second thing is, okay, once we've enabled our applications to be able to give us this data, we need to send this data somewhere. We need to be able to store and analyze it effectively. So we need to send this data to a separate external system that is really optimized and enabled to be able to do that, to have that store and to be able to analyze it as well. Once we've analyzed it, we then need to be able to understand it. And in order to understand it, it's much easier if we can provide things like visualizations and key insights into our systems as a whole. So having things like query capability, for example, really, this is really the key part of, okay, it's all well and good collecting data, but if I don't understand that data, how am I supposed to create any actions based on that data to be able to improve my application? So it's important that we have all three of these steps to be able to actually create effective observability within our applications. For step 2, you might be using tools like, for example, Jaeger, Zipkin, OTel Collector. There's lots of different tools you can use to be able to sort of have these exporters that allow us to be able to store and analyze. And for step 3, you might be using tools like Prometheus, Grafana, Kibana. Many of these are open source tools that allow us to be able to explore, visualize, build dashboards, provide analytics and interactive visualizations. So they can be really helpful tools for steps 2 and 3. But the one we're going to be focusing on today is really step 1. This is the key, especially when it comes to sort of integrating it into the development itself of our applications. And without this, we can't really achieve step 2 and 3. So this is the one we're going to be focusing on today. How do we instrument our systems and applications to be able to effectively collect that data? And this is based off, to make a system observable, we need to make it instrumented. And to make it instrumented, really what we mean by this is that the code should be emitting traces, metrics, and logs. And this is what we're referring to as the 3 pillars of observability. This is kind of a phrase used within the industry, this 3-pillar phrase. So while plainly having access to logs, metrics, and traces, it doesn't necessarily make the systems more observable, but these are all powerful tools that, if we can understand them really well and use them, can help us to unlock the ability to be able to build better systems, because we understand how they're behaving, can identify those bottlenecks and potential failure points, those sort of have that trace to the source error, and be able to fix that. Now, you might be thinking, yes, but there's more beyond these 3. And you're right. These are just the sort of key 3 that we're going to be focusing on this presentation. They're the key 3 enabled in the open source tools that we're going to be taking a look at. However, it is in the hope that with time, sort of in the future, tools like OpenTelemetry and other observability specifications and tools may be able to grow to be able to collect a much wider group of telemetry data, like, for example, profiling and end user monitoring, because both of these can also provide additional insight and information into how our end users are interacting with our systems and applications, and thus where we can potentially improve it on top of that. End user monitoring here is really about gaining real-time visibility into the user experience, so tracking the path of a single request, for example, understanding how it interacts with each service along the way. And profiling is all about understanding where our code spends its time and which hardware resources it consumes. Really, we can go right down to the individual line number within our class as to which one's primarily using more memory or CPU, for example. So both of these can be really helpful data points. However, right now we're just going to be focusing on the 3 that are enabled within open source tools at the moment, and that's logs, metrics, and distributed traces. You're probably already utilizing logs, and logs are a fantastic starting point for our observability data. Logs are found almost everywhere in software and have been heavily relied upon by developers to be able to understand system behavior. However, logs aren't extremely useful for tracking things like code execution, because typically they lack contextual information. So, for example, where they've been called from. So they can be far more useful when they're included within other forms of metrics, like, for example, traces, which we'll get onto. However, they are still a really good starting point and really useful to use, especially in conjunction with the other types of data. So it is, really recommended that we make sure that we have effective logs within our application. We can utilize normally logging tools within the tools we're already using. So, for example, OpenLiberty, that's an open source runtime, which we'll show in the demo. This is a cloud native runtime, similar to things like Quarkus, for example, and that allows you to be able to utilize, it has a unified logging component within it. And normally you can use the logging components within the tools that you might already be using. So I'm going to skip past logs just because, as I've mentioned, there are shortcomings to it. It is useful, but we're probably already using it. Then we go on to metrics, which is the second of these pillars. So when it comes to metrics, these are sort of, what do I mean by metrics? Really, it's about aggregations of numerical data. It might be about the infrastructure or the application. Normally, we can see these metrics over a period of time. And they can include things like CPU utilization, request rates, system error rates. There's a huge variety of different metrics that we can collect. And the great thing about metrics is that they're much more malleable to mathematical, probabilistic, and statistical transformations. So we can do things like sampling, aggregation, summarization, and correlation. And this allows us to be able to much better report the overall health of our system and how it's behaving. We can see that through these various different numerical trends. Metrics are much better suited to things like triggering alerts, and also things like they're more reliable in terms of we can run a query against a distributed system and aggregate those results before deciding if an alert needs to be triggered, for example. How can we achieve metrics? Well, again, there's lots of open source tools for this. So one example is MicroProfile. So if you've not come across MicroProfile before, this is a really awesome open source specification that was developed originally for anyone creating and developing cloud native microservice-based applications on Java. So it introduces many different behaviors and key components that are useful and sort of key to enabling those to be effective, that architecture style to be effective on the cloud when using Java. So it's also got some shared components and specifications with Jakarta EE. So if you're familiar with that, you may recognize things like JAX-RS, JSON-B, JSON-P, but there's also additional ones like the integration layer here in the second row and the observability layer in the top row here. The nice thing about utilizing MicroProfile within your applications is that because it's open source and it really is a community effort, you don't get any vendor lock-in like you might do, for example, if you were using Spring. And so there's lots of different compatible implementations that you can make use of to be able to take advantage of this specification and not have to change your code if you were to switch between these various different runtimes. So that's really helpful. You can check out the MicroProfile link at the top here to see which runtimes are compatible. In MicroProfile, there is a specification called metrics, and this can be really helpful in enabling metrics within our application. This specification is really all about providing a unified way for MicroProfile servers to export monitoring data. So again, we're talking about the telemetry data here, and it's all through this sort of unified Java API, and all about exposing our telemetry data, which is a key part of that instrumentation that we were talking about for this first step in the 3 steps of observability. If you want to check it out, we do have a guide on that, which I'll be showing you later on, and you can get hands-on with it. However, the biggest drawback with both application logs and application metrics is that they're both system scoped. So it makes it really hard to understand anything else other than what's happening inside a particular system. With logs without fancy joins, a single line doesn't give us much information about what happened to a request across all of the components of a system. So it's important that we don't just stop at having logs and metrics. We also need to have that third pillar, which is traces, to give us more of that system view and sort of combat this shortcoming of logs and metrics. So distributed tracing is all about addressing this problem of bringing visibility into the whole lifetime of a request across several systems, for example. So this is why we need this third pillar. Distributed tracing is all about it's a monitoring technique that links the operations and requests that may occur between multiple services. So it allows us to be able to trace, hence the name, the path of an end-to-end request as it moves from one service to another. What that allows us to do is to be able to pinpoint errors or performance bottlenecks, for example, to a specific individual service that may be negatively affecting the whole overall system. So we can really get deep into pinpointing exactly where the issue may be within that particular trace, within our system, and be able to take action upon that. Without tracing, it can be really difficult and challenging to be able to actually pinpoint the cause of performance problems, especially because we're now utilizing distributed systems. So this can really help to improve the visibility of our application's health and enable debugging behavior that can be difficult to reproduce locally. Now, when it comes to tracing, there are some key concepts that we need to understand when it comes to implementing it in our own application. So we've got traces and spans. So traces represent requests, and they consist of multiple spans. So a trace essentially describes the end-to-end journey of one or more connected spans. A trace is usually considered to be distributed if it connects spans performed on multiple services, which is often what we're using in cloud-native applications. Hence why we call this distributed traces. When it comes to spans, spans describe a particular operation or work taking place on a service. So spans can describe very broad operations. So for example, the operation of a web server responding to a HTTP request, or they can be as granular and specific as a single invocation of a particular function. So they have quite a broad definition, but essentially it's multiple spans that make up a trace. Then we have context. So in terms of context, this is really important to consider on top of just having spans and traces. So far we've identified the components of a trace, but we haven't described how those components then link together. This is where context is important. So context is all about contained in the span data to be able to identify the unique request that each span is a part of. This data is really critical for moving trace information across service boundaries. So as we're going between multiple services. Within context, we have two key components. We've got the trace ID and the parent ID. The trace identifier, this is a unique identifier that's generated in the very root span intended to identify the entirety of the trace so that we can track it right from the first span within this trace all the way through, and we can understand it's all part of one request, one trace. The parent ID is the span of it's the span ID of the parent span that spawned the current operation. So as you can see here in the second service, we've got the API web service. If you can see there, we can see that the parent ID is actually the span ID of the browser application, because that was the span there was the parent span that spawned this current operation. So what that allows us to do is to actually track back to which particular microservice within this trace caused that potential issue or bottleneck, because we have that parent ID and we can then follow the trace back and work it out. So with these two values, it's possible to determine the originating or root service and be able to reconstruct all parent or ancestor services in order that led us to our current operation. So really getting deep into the nitty-gritty of specifically where is my application going wrong, if it is, and why. So this is why it really builds upon the information we gain from logs and metrics, and it's important that we also include traces when we're enabling observability within our application. So now that we've looked at kind of what we need to do, how do we do it with tools? Because this has all kind of been very conceptual information at a higher level at the moment. And that's where we can utilize tools like OpenTelemetry. So in the past, the way in which code was instrumented would vary, usually because each observability backend would have its own instrumentation libraries and agents for emitting data to specific tools. What this meant was that for us as developers, it was kind of difficult because there was no standardized data format for sending data to a particular observability backend. If a company chose to switch observability backends, it meant that we had to completely re-instrument our code, configure new agents, just to be able to emit telemetry data to the new tool of choice. So this problem was recognized, and in order to solve that, OpenTelemetry was essentially created to provide this standardization. It is a growing community, and it's being contributed to by big players like Splunk, Google, Microsoft, Amazon, and many other organizations. It's actually the second largest, it's got the second largest number of contributors in the CNCF, the Cloud Native Computing Foundation, after Kubernetes. What it allows us to do is to be able to enable high quality, ubiquitous, and portable telemetry to enable that effective observability. It does this by providing, essentially, OpenTelemetry is like a catch for, it's a collection of different tools, APIs, and SDKs that we can make use of. It actually originated from two different specifications. So we had, or two different open source projects. We had Open Census and Open Tracing. Open Tracing provided a vendor-neutral API for sending telemetry data over to an observability backend. The issue with Open Tracing was that it relied on developers to be able to implement their own libraries to meet this specification. On the other hand, we had Open Census. This provided a set of language-specific libraries that developers could use to instrument their code and send it to any of their supported backends. However, if you can spot the issue already, that's two specifications, that's two standards, which doesn't mean we have one standard. That's kind of the definition of what a standard is. So in the interest of having one single standard, these two were merged to then form this new project, OpenTelemetry, or OTEL for short, in 2019. And it's a CNCF incubating project. And it's essentially trying to take the best of both worlds here from Open Census and Open Tracing. So this offers us an easy to use, pluggable architecture to enable us to add technology protocols and formats easily. It supports open source projects, and it includes metrics formats like Prometheus, for example, and it allows you to be able to plug into a variety of different backends like Jaeger and Zipkin. The reason I call that out is because it's really important to note here that OpenTelemetry itself is not a full end-to-end observability backend. So it's important that we utilize it alongside tools like Jaeger or Prometheus, because what OpenTelemetry is it just supports exporting that data to a variety of open source and commercial backends. It doesn't actually provide that backend. So that's why we're just focusing on the first step of the 3 steps of observability. Tools like Jaeger and Zipkin, other tools like Prometheus, Grafana can help with step 2 and 3, but OpenTelemetry can really help us with this first step of exporting this data and enabling it in the instrumentation stage. When we're using OpenTelemetry, the architecture will probably look a little bit like this. So in the middle, we have this OTel collector. OTel is just short for OpenTelemetry. Essentially, what this is a vendor-agnostic implementation on how to receive, process, and export telemetry data. So it's a single binary that can be deployed as an agent or a gateway that allows us to be able to take the OTel data from microservices or from our infrastructure, collect it, and be able to export it efficiently and in a standardized manner to any number of backends that we may want to use. OTLP, as you can see in the arrows here, that's used to be able to provide a specification for describing the encoding, the transport, and the delivery mechanism of that telemetry data between the telemetry sources and intermediate nodes like collectors and telemetry backends. So OTLP stands for Open Telemetry Protocol, and it's that protocol that allows us to have that standardization for all of these mechanisms of encoding, transport, and delivery. In terms of what's going on within the collector itself, as I mentioned, it's a vendor-agnostic implementation of how to receive, process, and export telemetry data. What having a collector allows us to do is really to remove the need to run, operate, and maintain multiple agents or multiple collectors. So it allows us to have that one central point in which all of our data is being received, processed, and exported. And this helps us to improve things like scalability. It supports open source observability formats like Jaeger, Prometheus, FluentBit, and others. And it allows us to send to one or more open source or commercial backends. The local collector agent is really the default location to which instrumentation libraries will export their telemetry data. So if you want to know more about the collector specifically, you can visit the OpenTelemetry documentation and find out more about it there. But that in general is OpenTelemetry. Now, bear in mind, this is still just an open source specification. You'll need an implementation to actually make use of it. And a fantastic implementation of this for the Java community, especially for cloud native, is MicroProfile telemetry. So this was a new specification introduced in the latest major release of MicroProfile, which was MicroProfile 6. It does adopt the OpenTelemetry tracing. Now, it's important that I point this out that OpenTelemetry, as a project, does support logs, metrics, tracing, and other things like baggage, for example. However, right now, the only one that MicroProfile implements is the tracing element of OpenTelemetry. It's hoped that in future, MicroProfile telemetry will evolve to include things like OpenTelemetry metrics and OpenTelemetry logging. However, currently that's not the case. There are some complexities around the fact that we already have MicroProfile metrics as a specification. But that is the hope that hopefully it will be merged in and you'll be able to make use of that as well. MicroProfile telemetry allows for that set of APIs, SDKs, tooling, and integrations, and it's really designed for us to be able to manage that telemetry data from our Java microservices in the cloud. The nice thing about the fact that it adopts OpenTelemetry means that we can benefit from a variety of different telemetry instrumentations, whether that be manual or automatic tracers. So we can have 3 different instrumentations when it comes to MicroProfile telemetry. There's automatic, manual, and agent. Automatic means if you're already making use of Jakarta RESTful web services and MicroProfile REST client, we can already automatically enlist some distributed tracing based on that. When it comes to manual, if you want to be specific about creating a particular trace that isn't enabled through this automatic, you can use things like annotations like @with_span, or you can utilize CDI injection using @inject tracer or @inject span. and we'll show some of those in the demo as well. There's also agent instrumentation, which allows you to be able to utilize OpenTelemetry Java instrumentation project to gather telemetry data without any code modification. That's also in the demo guide that I'm going to show, but we won't have time for it today. So please feel free, if you're interested in the agent instrumentation, to have a go with the guide yourself, and you'll get onto that in the later part of the guide. When it comes to how this actually works in our applications, you can see we have a couple of microservices here running with OpenLiberty. You can see that we're sending spans to a backend exporter to be able to actually see those within some kind of UI to be able to actually make sort of sense of them. And this is kind of the basis of how we're going to be utilizing MicroProfile telemetry with OpenLiberty in the demo we're going to show today. As I mentioned, this demo is based off an application that's making use of OpenLiberty. If you've not come across OpenLiberty before, then check it out. It is an open source cloud native runtime that really allows for all of these key benefits and behaviors. So really allowing developers, it was designed to allow developers to just focus on code. It was designed to enable you to make very fast and iterative changes. We have dev mode to be able to allow you to do that. Easy to write tests. We have some great integrations with technologies like test containers, for example, as well as sort of JUnit, unit testing, integration testing. It's ready for containers. And the nice thing is it's really designed to be sort of not in your way. It's not designed to be too bulky or heavy. It's a really flexible modular runtime that allows you to decide exactly what you want within it, so that it's not too bulky and big when you're deploying onto the cloud, but it's just the right size runtime while still providing you with those tools and flexibility that help to make that development efficient and effective. If you want to find out more about Liberty, I've got a link here at the bottom that will tell you about this open source runtime and sort of why it's beneficial and what it can give you. When it comes to how you use OpenLiberty, we have some fantastic interactive guides on our OpenLiberty website. We're really proud of these. We've got like over 50 guides, and we would love for you to have a go with them. They cover a variety of different technologies and topics to help introduce you to them and get you hands-on with them, including pretty much all of the MicroProfile specifications and Jakarta EE and many other tools like test containers, for example. We categorize them into different categories like develop, observability, security, lots of others, deployment. So if there's a particular topic you're interested in that I'm not covering in this presentation, feel free to head on over to the guides to check that out yourself. The nice thing is, for many of our guides, you can see this running cloud icon on the screen here. What that means is that you don't actually have to run the guides that are tagged with this on your local machine. So if you have security procedures in place that mean that you can't download local dependencies, the nice thing is we have this interactive cloud native environment that you can make use of. This is all based within a browser, so all you need is a browser. And what it has inside it is the instructions. It's got an IDE that's based on the open source Thea IDE and a terminal. So it's got everything you need in one. And I'm going to use this to be able to show you what it looks like, although it has logged me out. So I will just have to log back in. So essentially what I've done is gone to the OpenLiberty website. You can see here /guides, and you can see we've got tons of different guides that you can check out. Now I'm going to go to the observability section because I'm interested in this one. So enabling essentially distributed tracing with OpenTelemetry. And this time we're using Jaeger, but as I said, it works with different backends depending on what you're using. We just picked Jaeger for this guide. If you want to do it locally, you can follow these instructions, which will open when you click on that guide. But do bear in mind that you will need these prerequisites on your local machine if you don't already have them. In this, you can follow the instructions on the left-hand side, and the code will appear on the right-hand side when you need it. But instead, what we're going to do is we're going to run in cloud because I want to show you guys the cloud-hosted environment and just how easy it is to get it set up with this. You will need to log in for this, but there are lots of different social logins that you can make use of. Like, for example, I'm logging in with GitHub. Hopefully, as developers, most of us have a GitHub account of some sort. If not, you can log in with like LinkedIn, for example. You can also log in with, you can create an email login if you just want to create a separate login for this particular site. Unfortunately, the reason we had to add this is because we did have it completely open. And then unfortunately, Bitcoin miners found us, and we had to come up with a way to be able to prevent them from just being able to use our resources. So instead, you do have to log in. It will take a few minutes to set up just whilst the environment is getting started. So do bear with as this environment does take a little bit of time. Hopefully it won't be too much longer, and then I can get started with this lab. There we go. Perfect. Great. Hopefully this text is big enough for you guys. Please feel free to let me know if it's not. As I said, like, this is freely available, so if you guys want to have a go with it yourself, you are more than welcome to. Unfortunately, my other side hasn't appeared, which is typical. Let me try again. Here we go. Nope, it doesn't seem to want to. It worked about 5 minutes ago, and typically it's not working during this presentation. I might have to try and redo this, see if I can get it up again. If I can't, I have a video recording that I can show you guys of a GitHub repo we have that you guys can check out yourself as well, if you want to try that instead. Yep, unfortunately, it looks like, let me just see if unfortunately, my left-hand side, my terminal and my IDE aren't coming up. I'm not sure why. So instead, I will show you, if I exit this, I will unhide these and show you the video instead. Unhide and unhide. There we are. Cool. Okay, so for this particular video, we're using this repository that we have in the open source. This was made by a colleague of mine called Jansen. If you want to check it out, it's all open source, so you can. The link is at the top here. Essentially, what we're showing here is we're going to open up Visual Studio Code and take a look at our application. So you can see here we've got the instructions that you saw. They're pretty much the same instructions that are based on the lab as well. So we're just going to clone that repo and open it up in Visual Studio Code. Now, the important thing to notice here is that because we're running this locally, we do need to enable our local dependencies. So for this, we need to make sure that our backend is also set up. That's automatically done for you pretty much. We have a Docker command that you can use in the online environment. So we're just going to open this up in Visual Studio. What you can see here is that we have two microservices, inventory and system. And inventory essentially keeps an inventory of the system metrics, and system microservice is calling that to be able to scrape those metrics every 10 seconds. So before we get started, we need to get the backend set up. For this, we're using Jaeger. We're just going to follow the Jaeger getting started instructions. If you'd rather use Zipkin, you can follow the Zipkin quick start guide if you want to use that instead. We're going to use this all-in-one executable, which has been designed for very quick local testing. So we're going to launch the Jaeger UI, collector, query, and agent with an in-memory storage component. So you can see here, all we need to do is navigate to this localhost URL to be able to access that Jaeger UI. So if we open up a new tab, open that up, and what you'll see is, yep, cool, Jaeger is up and running. We have a backend that we can connect to. As you can see, there's not really much going on at the moment. So let's switch back to our IDE and get started on actually implementing MicroProfile telemetry. So the first thing we need to do is ensure that we have the feature for our server.xml file for MicroProfile telemetry. So let's have a look at system first. So in order to find the server.xml, we're going to go into Liberty and then server.xml. And you can see we already have that feature enabled, MicroProfile telemetry. You can also see I'm using others like JSONB and CDI. Now we're going to go into our config, MicroProfile config file. We need to make sure that we're specifying that OTel SDK disabled is false in order to actually enable tracing. Weirdly, by default, MicroProfile telemetry tracing is off. So we need to make sure we're setting that to false to make sure that it's enabled. So now we're going to test our automatic instrumentation. We're going to need to get the system microservice up and running for this. So for this, we're going to be using Maven Liberty Run. So we're using Maven. You can use Gradle if you want to. For simplicity's sake, we just use Maven in all our guides so that you don't have to keep switching between different build tools, but you can use Gradle if you wish to. We're just using Maven Liberty Run for this because we just want to show you how it looks. We're not making changes on the fly. You can use Maven Liberty Dev if you want to use dev mode and see those changes happening in real time. Now that it's up and running, we can check that our endpoint is working, which we just showed. Now, if we go to the Jaeger UI and refresh, you can see our telemetry data is here. You can see in the drop-down menu, I have the option to select system, and then I can find all the traces. You can see there's one span that has been found for this microservice, and we can click on that to see further details, as you can see here. So that is the automatic instrumentation. So as simple as just making sure we have it in the server.xml as a feature that we need, and in our MicroProfile config file, ensuring that we specify that OTel SDK disabled to false. Because we're already making use of MicroProfile REST client and Jakarta RESTful, we have automatic traces set up for us, really without much work at all. This next one is all about, okay, what if we want to be able to set up manual instrumentation rather than just the automatic instrumentation? So again, we're going to need some prerequisites for this. So third-party APIs have to be made visible in our app in the server.xml. So that's the first thing. So we're going to head into that server.xml for the inventory microservice. And in this, you can see we've got this line here where we say API type visibility third party. So we're enabling third-party APIs to be made visible to our app. The other thing we need to do is OTel API and OTel instrumentation annotations need to be provided as dependencies in our build path. So in this case, because we're using Maven, we're going to add it to our pom.xml. So you can see here is where we need to add those OpenTelemetry dependencies. So there we've got two dependencies we need for OpenTelemetry API and for the instrumentation. Now we're ready to instrument our code manually to be able to create traces. So we're going to head into our inventory resource class, where we're going to be injecting a tracer and span object, which we're going to be using to create those spans manually in this case. So in this case, we're creating a span called getting properties, which adds an event before the system service is called. So we've already got it in place here. We're just going to uncomment many of our, So we've got the @inject for the tracer. We've got the @inject for the span. And we're just going to add in the required, So this is where we're creating this span for getting properties in the system service. So if we head back to our IDE, you can see I've already got it here. We're just going to uncomment that. So you can see we're utilizing that here. We're adding span names. And what we're also going to do is we're going to create a new span by annotating the methods in any Jakarta CDI beans with the @with_span. So we're going to do this in the inventory manager.java file. And we are going to head into that file now. And we're going to annotate the hostname method parameter. So this time we're going to use that @span attribute annotation to indicate that it's now part of the trace. We can name spans with the @with_span annotation. In this case, we're creating it and we're giving it the name list, as you can see here at the bottom. Great. So as you can see, we're giving it its own name. We have a separate @with_span in this IDE, in this class. So we can copy that, but we've already got it in place here. So we just need to uncomment that. Perfect. So now that we created these spans manually, we can now build the inventory service and deploy it. So first, we need to check again that we can successfully access the endpoint. Bear in mind, we do need to run both microservices in this case. So we are going to run the system microservice and then the inventory microservice. Again, we're just going to use Maven Liberty Run for this for each one. So here we can see it's starting up for us. And then we're going to create, we're going to have a new terminal and CD into the inventory microservice and get that one up and running as well. So again, just Maven Liberty Run. It shouldn't take too long. Once you see, there we go, the default server is ready to run a smarter planet. This is the sign that our microservices are up and running. So again, we want to check that our inventory endpoint is still working as expected. There we go. We can see it. It is. So now we can head back on over to the Jaeger UI. This time, we want to make sure that we're looking at the inventory to find the traces from that. So if we head back to the Jaeger UI, what we should see is something similar to that screenshot there. Because we started this again, there we go, there's the URL. If we head on over to that, what we should see now on the drop down is that inventory rather than just system. And when we click find traces, you can see that this time we can see 5 spans and 4 of them are from inventory, 1 from system, and that we can click on them to dive into further details. So we can get further detail on them, as you can see here. So that was a short demo just to show how easy it can be to get started with both automatic instrumentation and manual instrumentation using those annotations, which are sort of key and very commonly used within MicroProfile specifications. This time we're using @with_span annotation, but previously we were also looking at using the other annotations as well. So hopefully I've shown, although not in the cloud hosted environment, so I'm sorry that didn't work today, but at least we had the video backups. So hopefully I've shown you throughout this presentation that entering a world of increased complexity is what we're facing as developers, and we need to be better dealing with that in terms of really making sure that our applications are ready for that complexity. And effective observability is crucial to be able to actually achieve that. So if we want to enable our applications to really thrive within the cloud environment, we need to enable effective observability to monitor and understand how our applications are behaving and performing in this complex environment. But the nice thing is that there's many different open source tools and technologies to help us look through that looking glass, to create that effective portal, to step into that world of Alice in Wonderland or the Matrix and really enable that sort of portal-like vision into our applications in that distributed environment. And these open source tools include new standards like OpenTelemetry, and for open source Java tools, MicroProfile telemetry enables us to actually make use of this specification and this standard in our own applications. If you guys did fancy some additional resources, we have some really great links here that can provide great learning and sort of a recap of what we've discussed in this presentation. So there's the What is Observability link here. We've also got OpenTelemetry and MicroProfile article that you can check out on IBM Developer, and then also a blog on how to use MicroProfile telemetry in your own applications on our OpenLiberty blog. If you want to find out more about OpenLiberty, find out more about things like dev mode, or even some of the newer technologies we have, like, for example, Instant On, which enables really fast startup times, getting close to sort of serverless times, using technologies like Crack under the covers and Cryu, so checkpoint restore, to be able to enable your application to restart from a stored checkpoint. So really enabling rapid startup, graceful shutdown, and sort of enabling those really fast startup times. So there's some fantastic benefits to OpenLiberty. It is an open source runtime, so you can check us out on GitHub, but you can also connect with us on social media if you want to find out about our latest releases or any of the new guides that we're creating. We're constantly creating new guides. So if there's a particular guide that's missing, please let us know. Or if there's a particular guide you love, please also let us know, because we're always looking for feedback. We're always looking for ways to improve and for new guides to put into our backlog for us to create. Please do connect with us either on LinkedIn or Twitter. I run those accounts, so I'd love to say hi to you guys and find out more about what you think. So unfortunately, I'm sorry that the guides didn't work, but please do also go and check them out. As I said, we have a plethora of different guides. I think it's just because I had it up running. I was trying to be clever and have it up ready for this presentation, but I think I just timed out and it's just, for some reason, caused it to crash on my particular machine this morning. But hopefully you guys will be able to make use of that running cloud. Otherwise, feel free to use the local hosted version. And you can utilize the filter to be able to search for them, or the menu on the left-hand side. And yeah, please let us know your thoughts and have a go yourself. So with that, I'm going to say thank you so much for listening. I really appreciate your time. If there's anything you want to reach out to me about, feel free to contact me on LinkedIn or Twitter. My details are on the screen there. Thanks so much.
Thank you very much. That was an amazing presentation, and I was actually finding myself looking for that icon or reaction that I could send in the stream, but not on this platform. Maybe in the next version. So we still have a couple of minutes for a couple of questions. So if you don't mind, right? Great. The first one would be about the patterns of observability that developers need to implement. So there is the automated instrumentation that make it easy probably to start and to kind of touch the surface of what observability patterns allow to achieve, right? But what about one level deeper? Do you have some recommendations about how to choose the places in your code that deserve the observability tracing, right? And or maybe it should be like a reactive thing. Hey, we need to debug this part of the application because it's slow, so let's add more traces there. Or it should be proactive, where you say, hey, I suspect that every asynchronous call should be traced. What's your approach?
I would say a bit of both. It's very difficult to be able to proactively account for every possible situation, every possible trace. As great as our architecture can be, things can change, and maybe we're not keeping a track of that. So I think it's a mixture of both proactive and reactive. So I would say where you can, try and be proactive about enabling observability for every single sort of request trace that you think could happen across multiple microservices. So let's say scenarios where I'm creating a holiday booking site, and I know that if someone's booking a holiday, they're going to need to touch my booking service, my payment service. They're probably going to be touching different microservices for accommodation, flights, taxis, for example, and that's all going to be part of one request. So if I want to know where a particular request for a holiday goes wrong, then I'm probably going to want to be able to have tracing enabled across that particular sort of route. So it's about planning these routes that users may have to take or requests might take through your system and enabling it where you can proactively. However, there's probably going to be times when a request route does something weird and goes through a path or a route that you weren't expecting or you didn't necessarily plan for, in which case you can still sort of retrospectively and reactively apply observability to be able to find those bottlenecks and potential failure points.
Thank you. That is indeed a good approach, like basically being smart, right? So figuring out what are the possible hot routes within your application that you might want to add a little bit details into, right? But then reacting on the other routes that were not predicted initially, right? Yep. One more question is coming about standards. Like we all know there are standards, they are open, but then there are implementations that might or might not adhere to the standards, and they may extend the standards in the various ways, etc. So sometimes it is more or less organized and well structured, and in some other cases the standards grow into this pretty wild ecosystem of little add-ons, little features that might or might not be turned on or off. At which stage we are right now with OpenTelemetry and generally in this ecosystem?
So I would say that the fact that OpenTelemetry is within the CNCF Foundation, it is part of a very established foundation with a very active community working on it, which involves a plethora of different individuals, but also companies and vendors. So I think it's in a really good stage in terms of they've already made this big decision to merge two existing projects so that we actually have one standard. So we're already moving in the right direction. Now, it's still sort of an incubating project, so we do still need to be aware of that. But I would say the fact that it's at least moving in the right direction to produce one standard instead of two, which sort of never made sense. And also the fact that we're in this established foundation allows us to have greater confidence that it's probably not going to change wildly or dramatically, and that it should hopefully be offered and implemented by a variety of different vendors. I would say the same thing for the fact that MicroProfile has picked it up is a really great sign, because clearly they also believe that it's a fairly sort of solid, stable specification that they can make use of for enterprise Java, not just for Java, but for enterprise applications who clearly need that stability. So the fact that they put that vote of confidence into it, I think is a really great sign.
Thank you very much for your answer, and I think we're running out of time, so if there will be any more follow-up questions from the audience, thank you very much for sharing your social media contacts. So I think people will be happy to reach out and explore more some of those tools, especially since you've shown that it's really so easy to start and there is no excuse not to use those tools or those approaches in the own project. So thank you very much. It was a pleasure to have you in this conference.
Thanks for having me. It's great to join you guys.